All right, so once again, we're here at the American Astronomical Society meeting in Honolulu, Hawaii, and I got a chance to catch up with David Kipping.
Yeah,
David,
thanks
great
for having
to
me,
see
Fraser.
you in person, finally.
Yeah, it's great to be here. Hawaii is, probably one of the most spectacular places you could possibly be asked to go for a conference, and this meeting is a wonderful place.
Well, that's what I'm told. I mean, I don't think I've left the halls of this building except for walking to and from
You're
the hotel.
probably working a bit harder than I am,
Maybe.
but it sounds like,
Yeah, Chad at some point got a chance to feel the sand in between his toes before I dragged him back to work. So, you know.
It is like paradise here. So
I know.
This is one of the plus sides of being an astronomer, is that we get to sometimes travel to places like this and talk to our colleagues here. So yeah.
Now, you, of course, do the Cool Worlds lab at Columbia. So give people a bit of a information on that.
Yeah, sure. So the name of my research group is actually the Cool Worlds Lab. And we named our YouTube channel after that, so it's called Cool Worlds. And people always ask me, like, why did you call it Cool Worlds? Is it like, are they cool? Dope, like does it mean that? And it's really because we're interested in planets which are not hot Jupiters. Is probably the simplest way of saying it. These are planets which are far away from their stars. They could be potentially habitable. They could have liquid water on their surfaces, or even beyond that, they could have icy rings or icy moons. And of course, something we're well known for on my team is thinking about looking for exomoons. So these planets have always been special to me. We named the team after it, and then we started our channel where we talk a lot about our research, of course, but we also get into some of the more interesting ideas about, are we alone in the universe, and future possibilities, futurism in astronomy and interstellar travel prospects and things like this as well. So
a topic that I wanted to talk with you that I've been thinking a lot about, and you did a whole video sort of at the end of November about this, was just this idea of, like, we always think about our efforts to observe aliens, to explore the universe, to try and detect signs of biosignatures. But there is always this counter to that, which is the more you realize what we're capable of observing out there, you have to think, if the aliens are out there, are they observing us here?
Yeah.
So what have, based on sort of the current state of the art, what do you think about how other civilizations could be observing us?
I mean, yeah, when you look ahead to the sort of telescopes that we're developing, and even to some degree already have, you can already establish that if an alien was watching the solar system, either they might get lucky, and if they're in the ecliptic plane to us, they would see us transit in front of our star. That would reveal an enormous amount of information to them. So they'd be able to tell how big the planet is, they'd be able to tell our orbital period, they'd be able to tell that there was at least the right temperature for liquid water on the surface. And if they had the capabilities of James Webb Space Telescope, or maybe something a little bit more powerful than James Webb, they'd be able to smell the atmosphere. So they would be able to know that there was oxygen, ozone, maybe even the pollutants that we produce. So you can think about the chemical pollutants that factories are producing. That kind of stuff would be detectable. CFCs, for instance, using futuristic, but maybe not super futuristic, like 20 years ahead of us, telescopes. So I think if there was an alien civilization watching us and we were transiting, they would almost certainly be able to tell that not only is this planet habitable, inhabited, but there is a civilization making do and maybe developing on this planet. If the planet was not transiting, it gets a little bit harder. They wouldn't have that shortcut, but they would still eventually surely be able to detect us. We're thinking about building this telescope called LUVOIR and HABEX right now. These are telescopes which will take direct images of the Earth. They'll block out the sun, just reveal a photo of the Earth, and then you could figure out all that information in the same way.
And what are some of the other ways that we are leaking our existence to the universe? I mean, you talk about making a direct observation of the atmosphere, but when I think about humanity's impact on the planet, that's just one tiny fraction of everything that we're doing.
Yeah.
So what else are we doing that maybe aliens would be able to sense?
Yes, there's a slew of ideas, and these kind of come into the ideas of what we call techno signatures. So, for example, there's the heat island effect that cities have. I know this from New York City. That there's in the summer it's like 2 degrees, 3 degrees Celsius warmer in New York City than it is in the rest of the state. And so actually you could see that if you had an infrared telescope which had the ability to resolve the surfaces, and that's actually not completely impossible to imagine building something like that. The Colossus telescope is an example of a telescope that really wants to do this. Then you can actually figure out that there are heat pockets which are consistent with what you'd expect from cities, and you can even calculate that the temperature difference is kind of similar to what we have here on Earth with the heat trapping effect.
So you could literally just detect the heat from the cities
Yeah.
as the planet is turning.
So you'd be able to tell, you can imagine taking this a little bit further and having like mega cities and things on these worlds, and being able to tell, okay, there's basically 5 or 6 metropolis islands on this planet, and it looks like most of the population are living there. You could maybe even use that information to say something about the distribution of continents and oceans and the habitable regions of the planet itself, of course. And then in space, this is very poignant right now because with Starlink going up and sending many, many more satellites into space than we've had in the past, there's increasing interest that perhaps we could even detect the satellite systems, the artificial satellite systems of other civilizations as well.
Would that be like by the glint of their, like how would you actually, the heat from them, how would you detect that?
If there's enough of them, then they will cast a shadow when they pass in front of the star. So it's like having a swarm of dust almost around almost like a
Like
ring,
another atmosphere,
essentially.
yeah.
So you'd have a ring system that would be made up of very large particles. These are like boulder-sized objects. The reason why you'd probably be able to tell that they were artificial is because they would live in the what's called the Clark belt. These are the orbits which are geosynchronous with the Earth. So if you saw there was a collection of satellites which are preferentially found in a location which happens to be geosynchronous with the planet which it goes around, there's no reason naturally why satellites would find themselves in that configuration. That would be a pretty clear indicator that somebody had put that there to monitor their own planet.
Okay.
So these are the kind of things we're getting interested in. You can even think about in the future climate change solutions. There is some talk of building a giant shade in space to cool down the Earth. It's one of the more extreme options for saving Earth, but if another civilization runs into a similar problem, they may very well do that. And these shades are huge, so again, there'd be a very easy signature for us to look for. Possibly a glint, but probably the most easy one again would just be the light it blocks out as it passes in front of its star.
And it would give like a very specific signature that would be absolutely artificial to see this thing pass in front.
Yeah, and also the location would probably give it away again. So you'd see the stable position for it would be in one of these Lagrange points in between the Earth and the Sun. A Lagrange point is kind of a point where the gravity of the Earth and the gravity of the Sun are sort of balanced out, and so you have stable or quasi-stable orbits there. And we are putting, for instance, the James Webb Space Telescope in such an orbit, and many of our future telescopes are going there. And so if you see someone putting a collection of material in this location, it's a little bit suspicious because there's obvious technical reasons why a civilization would prefer to put stuff there. And of course, if you can see it transiting, you would know actually the shape based off the transit light curve. We did some work in my team on this. Emily Sanford, one of my graduate students, we came up with this idea called shadow imaging. So just from the way in which the star decreases in brightness and then comes back to its normal brightness, you can use that dip to figure out what was the shape of the thing which went in front of the star. And so you could potentially figure out this thing is not a sphere, it's a giant triangle or a giant sheet of material that's been put in front of the thing, and then that would obviously be a very clear indication that somebody put it up there.
And that would be like if an alien civilization wanted to give us an easy way to find them, they could relatively inexpensively put up something weird like a triangle or something to orbit around their star, and that would be detectable.
Absolutely. That's an idea from Luke Arnold as well, which maybe you're thinking of there. So he wrote that idea in, I think, 2003. And he had this idea to not even just a triangle, but you could even have some primitive communication. You could even have like pillars of material which pass in front, and they could have like the prime number sequence or something encoded within them. So you could have like some very simple...
We do math.
So there's certainly a lot of... Personally, I kind of think that's a little bit of an expensive way of doing it. The advantage of that method is it kind of lasts forever. It's like a beacon that you build that doesn't really require any more power. Once you've built it, it will last forever and it'll just maintain itself.
We were here.
But it takes a lot of energy to build the thing in the first place. So when we read that paper, we had this idea of, hey, why not use lasers instead? Because there you can create all the same kind of bizarre transit shapes that you want to create. Yes, you require power to do it continuously, but at every single instance that you want to do it, the power requirements are very modest. You're talking like megawatts of power, whereas to build, a planet-sized disk at the orbit around the sun very close in, that's just unimaginable amounts of energy compared to what we can do. So this is something we could actually do right now using lasers.
Now, what about our radio signals? Now, obviously, messages have been sent out into space, but people always are fascinated by this idea that there is this bubble of radio transmissions leaving the Earth from the moment we started transmitting. How detectable is that right now?
It would be difficult to detect a lot of that leakage radiation, and increasingly difficult as time goes on. A lot of our communications are actually switching from radio transmissions to using fiber optics, because it's actually far more efficient to send information that doesn't leak. You don't want that leakage. That's the opposite of what you want when you're sending data. So there's been a window of maybe 100 years where we were fairly radio bright. But even then, to detect Earth's own leakage, you would require, things which hundreds, maybe even a kilometer-sized radio detector at sort of 10, 20 light years distance.
Yeah, but a kilometer-sized radio detector is under construction right here on Earth.
That's true. So it's if there was a dedicated program here, using the SKA, for instance, that would probably be your best bet, that was primarily focused on looking for leakage. I think they could maybe put some interesting upper limits, probably only out to sort of a distances of tens of light years.
That's what I'd heard. I've heard that the square kilometer array will be able to detect, say, air traffic control out to about 100 light years away.
Yeah, that sounds kind of similar to the...
And so if somebody wanted to make a beefier version of the square kilometer array, something that was the square 100 kilometer array, the square 1,000 kilometer array, something in space, something with a giant baseline, a giant space-based radio interferometer, where the only goal is to sense alien civilizations.
Yeah, I don't want to dismiss the idea out of hand, but I think my personal... This all comes down to personal beliefs a little bit when you're talking about looking for techno signatures, but my personal sort of belief is that it's intrinsically wasteful to let that energy escape into space, and you can just send so much more information down a fiber optic or a laser beam than you can by using these isotropic or high gain antennas that I think civilizations... This is all, again, just xenopsychology, guessing what another civilization will do. Yeah. My guess is that radio transmission is a sporadic thing. They do it for a short interval of time, and then they'll eventually transition to something that really becomes fairly difficult to detect remotely.
And what about something more exotic, like the neutrinos coming out of our fusion reactors, or things like that as we transition into new technologies?
Yeah, that's, I think there is a little bit of literature about that. Certainly if a civilization was using a lot of fusion energy on their surface, that would produce a neutrino flux. There is some work, I think, looking at whether the ice cube detector, for instance, could possibly detect that. It would be a little bit challenging to send any information or interpret any information with a neutrino beam, but maybe you could detect that there was a spot in the galaxy that was anomalously neutrino bright. Whether you could then assign that, therefore that means a civilization unambiguously, I think that would be difficult, right? Because how do you know? We see this all the time in astrophysics, like the fast radio burst recently, or Boyajian star. Just because you see something that's surprising or anomalous, yes, you could explain it with aliens, but very often it just turns out there's another explanation down the road. So my favorite techno signature is something that's a little bit less ambiguous than that. So I think if you had a prime number sequence, so that's, for me, that would seem to be a very difficult thing to imagine the universe naturally producing without an intelligence behind it.
But that's assuming that the civilization like us, we want to share with the universe that we exist.
Yeah.
And so on the flip side of this, been some great science fiction written. A lot of people are familiar with this book, the Three Body Problem,
Yeah.
and they have this idea of what's called the dark forest. And in the dark forest, you haven't gotten there yet, but the gist is that
Spoiler alert.
yes, the universe is a dangerous place, and it's best to keep your head down.
Yeah.
And as we learn more, as we develop our capacity to be able to see the larger universe and potentially detect these other civilizations, and we start to come to realize how vulnerable we might be, what can we do to kind of rein that in and mitigate the messages that we are, so less techno signatures? What can we do?
Yeah, I mean, this is very much what Stephen Hawking was sort of speaking about before his passing, of course, was that he was very worried that, METI, for instance, the active SETI component, where you really broadcast messages out saying, hey, we're here, please come and talk to us. He was not supportive of that
Right.
at all, and felt like, we should stay quiet because maybe he'd read the Three Body Problem before it came out or something.
Yeah.
I don't know. But and I can understand that. Again, I think I'm a little bit skeptical of it, that we could genuinely hide ourselves at our current technology level from a truly much more advanced civilization. We have been a very simple species for the last million years, right? We were living in caves and hunter-gatherer civilization before that. So this episode we're in appears to be fairly transitionary. We will probably at some point stabilize out to a more advanced state. And it's very difficult to hide ourselves from this unknown capabilities. We already talked about how they could detect the atmosphere. They would know there was pollutants in the Earth's atmosphere, for instance. They could detect our satellites around us. Maybe in the future we might do asteroid mining and activities like this, and that would even more give us away. So I think it's going to be difficult to truly hide ourselves. So personally, I'm a bit more on the side that it's a little bit futile to get too hung up on it. Although having said that,
You did a paper.
I did a paper which kind of pointed out that we could hide ourselves from certain types of surveys. We could hide ourselves from our own technology. Could we hide ourselves from a much more sophisticated technology? I mean, who knows? Because who knows
Right.
what that technology even
So
looks like.
talk about that. So how would you hide yourself from the transit astronomers, the alien transit astronomers?
Yeah, I feel really bad about this paper because the title of the paper was, I think, a cloaking device
Yeah.
for transiting planets, which just sounded so cool that we had to
Clickbait.
use
Yeah.
it. Exactly.
Yeah.
It was like, that's such a slick. I was, a big Star Trek fan, so the idea of having like a Romulan version of a cloaking device was
Yeah.
like, that would be awesome. But actually, one of the most important messages of this paper, before I talk about how we do it, is that this exact same system that we can use for cloaking the Earth could also be used to broadcast our presence very efficiently and cheaply. So the idea is that, when the most successful method for looking for exoplanets right now is the transit method. I'm sure your viewers have heard about this many, many times, but in a nutshell, it's just when you have a planet pass in front of a star, it blocks out some of the light. And that's really all it is. So in order to hide that planetary signature, you just need to do the opposite. You need to emit a little bit more light off the other side of the planet during the transit, and lasers are a very efficient way of doing that. Because they're collimated, which means the energy is trapped within a very confined beam, then you don't have to outshine the star. I mean, the star is obviously 10 to the 26 or something watts of energy, but it's going out in all directions randomly. Whereas a laser has all of, it's much less energy, but it's confined in such a narrow region that when you view it down the beam, it can actually be comparably bright to the star. And so that's kind of the idea that if we were concerned about hiding ourselves, we could easily calculate when stars in the ecliptic would all be able to see us transit. We could easily calculate when they would see us transit. And just for about 6 to 13 hours, depending on how far in and out of the plane they are, we would just shine a laser on them, turn it on, about a megawatt laser for something like a few hours, wouldn't really cost too much energy, and we would be able to essentially remove our transit signature.
Wow.
And you can even, if you wanted to, just selectively remove biosignatures, for instance. So you might say, let's keep the planet in there, let's just hide the variations on top of that, which are caused by things like ozone and things like methane in the atmosphere, things which would give away that the Earth's inhabited.
Right.
So then the Earth looks like there's a planet there, but it looks like a dead world.
So how do you hide the chemical fingerprint of of ozone in the atmosphere.
Well, it's tricky, but I think it is doable, even with a little bit scaled up from today's technology, maybe. So there's these super continuum lasers which exist. Now, I'm not someone who builds lasers or works with lasers regularly, so this is all sort of reading of the literature.
Yeah.
But these lasers, they're kind of clever. They can tune the frequency they're using, but they can tune it very, very fast, so they can kind of sweep across the spectrum very, very quickly. And you can ask it to sort of hang around at one frequency a little bit longer than other frequencies,
right.
and that can therefore cause it to create a spectrum.
Right.
And that spectrum would almost be the inverse of the biosignature spectrum, and thus you would just sort of cancel out the ozone feature. Like there's a big divot in the absorption line of the ozone, you just sort of scooped that out,
right.
just in the same way that we do for the entire transit if you want to do the whole transit. So it would take a little bit of finesse, but I think it would be quite plausible to, at the very minimum, attenuate that signal right down, or even completely remove it and make it look like the planet is not as
right.
habitable as it might
right.
first appear.
Hide the cities, hide the chemical fingerprint,
yeah.
hide the, even the transiting of the planet if you needed to, so that any alien.
Yeah.
So, if there are alien civilizations out there, do you feel fairly certain that they know we're here, or that there is at least life on life on this world? So
okay, I'm going to take your question fairly. That assuming they are out there, if I assume they are out there, and my own opinion is probably the opposite of that. But if I assume they are out there, then I think they would. If they're within a 200 light year bubble of us, then I think they would know there was industrial activity happening on the Earth. If they were further out than that, then of course there hasn't been enough lifetime travel yet for them to know about us. But they would know, I suspect, the Earth was a blue inhabited marble, where there was evidence of photosynthesis, there was evidence for a red edge, which is a clear signature of photosynthesis on the planet, and maybe they'd see the ozone. So I think most of the galaxy, if they had sufficient telescopes to do so, would clearly be capable of knowing that we were here. So.
And when will we know where they are?
Well, that's what we're trying to build right now with these new telescopes. James Webb is probably the first serious strike that we have at maybe doing this. It's only going to work in very niche cases.
Right.
So if we had a very, Proxima Centauri B, if it was transiting, would have been almost the perfect target for it. You need something that's a very small star with a transiting planet in front of it, and it needs to be very close by to us.
Yeah.
If you kind of tune all of those parameters just right, then James Webb has a shot at detecting biosignatures if it used up a very significant portion of its observing time. But it's just about doable. Right. Hopefully TESS might find some planets just right like that. I mean, we even heard about 700D, TY700D yesterday, which I don't think is maybe quite the right target for James Webb, but it's sort of an example of this. And then down the line, we're hoping to build these grand observatories that we've been speaking about at this meeting, things like Habex and Louvois, whose principal objective is to image these planets, which is very exciting because then you don't even require a transiting planet anymore. They could be in any configuration, more or less, and you could take photos of these things, get the spectrum out, and just like how Carl Sagan talked about the Earth being a blue dot, you'd really see these blue dots in your images, and even be able to detect all the biosignatures in the atmosphere. So that would be something that we're talking about in the 2030s, 2040s, being able to do.
So we're like a couple of decades away. So you hear that, aliens, you got like 30 more years. Hide yourselves now, because we're coming. Yeah. Well, we're not going to get anywhere near them. That's a whole other issue. David, great to chat with you today. Where can people find out more about what you're working on?
Sure. If you go on YouTube, we have our YouTube channel there. It's called Cool Worlds. You can just /Cool Worlds Lab, and you'll find us on there. Or you can even follow me on Twitter at David_Kipping.
Great. Thank you so much.
Yeah, my pleasure. Thank you, Fraser.
All right. Great. All right.
Okay.
Perfect.